All right, today we are doing 6.5, day 1. We are going to solve equations using the rational root theorem. So when we do this, we can pull in other methods that we've already used, like synthetic division, like factoring, like the quadratic formula. We might still use any and all of those things. But we are going to be solving these problems on our own from start to finish. All right. Our notes. You have learned several methods for finding the roots of a polynomial equation. Another method involves analyzing one or more integer coefficients of the polynomial. Okay, to kind of introduce this, we are going to do this problem. If you don't have enough room to write the whole thing out on here, that's fine. This is not an example. We're going to try to answer this question down at the bottom. We're going to solve the equation given that x plus 2 is a factor. And we're going to answer the question, what do we notice about the solutions compared to the original problem? So if you don't have room to work this whole problem out, that's fine. The important part comes once we get the solutions and we compare them to answer that question. Okay. All right, so I'm going to create myself some space. This problem is actually similar to problems that you would have had on your quiz yesterday. If we're given one factor, what did we use to break this down and be able to factor the rest of it? Wonderful. We use synthetic division in order to factor it further. Okay, so it's in standard form set equal to 0. They gave us one factor. To be able to keep factoring it, we use synthetic division. What number goes in my little box? Negative 2. What are my coefficients across the top?
1, -5, -2, 24.
Okay. If I am using synthetic division to factor, I better get a remainder of 0. So let's see how this works out. Drop the 1, multiply, add them together, multiply, add them together, multiply, add together. All right. We got our remainder of 0, so that's good. I need to rewrite this using my variables again. My problem started with an x cubed. My answer starts with x squared. So this becomes 1x squared minus 7x plus 12. And we want to factor that. What goes in the front of my parentheses? X goes in the front. What are my signs? Minus, minus, and my numbers. 3 and 4, 4 and 3. Okay, they multiply to a positive 12 and add up to a negative 7. What's my other factor?
2
X plus 2 is my third factor. If I'm solving this, then I need to set each one of those equal to 0. X minus 3 equals 0. X minus 4 equals 0. X plus 2 equals 0. All right, when we solve those, we get x equals 3, 4, and negative 2. Okay, if we were to bring back that question at the bottom, let's see if I can find it. What do we notice about the solutions compared to the original problem? Now, what's the opposite? Okay, so the numbers that we get for x are always the opposite of what they appear to be in the factors. That's true. But what about compared to this polynomial that we have? It's a little bit tricky. Could all three of these numbers divide into any of the numbers up here? Which number? the 24. All of these could divide into or are factors of 24. So what we wanted to notice here, this was the goal, and I understand it would have been hard to pick it out on your own from nothing, but these solutions are factors of the constant. Good job using those math words. Okay, the solutions are factors of the constant. That is a lot of what today's lesson is based on. The constant was 24. The constant is the number that does not have a variable with it. All right, the rational root theorem is a very, very, very long way of saying that any possible rational root for a polynomial, okay, all these a, x's, and n's here, all this represents is a polynomial function where at the very end you'll notice a sub 0. All right, that a0 on the very end doesn't have an x, so that's our constant term. The one in the very, very front, that's our leading term, so our highest degree. So a sub n would be the leading coefficient. Okay, so what this is saying is that any rational root or zero solution of a polynomial is going to be a factor of the constant over a factor of the leading coefficient. This is what's important for you to know. Using this, we can find possible rational roots, rational meaning integers or fractions, not the ones that are going to involve an I. So let's practice doing this. Okay, here we are going to find the rational roots. Now, in order to do that, the first thing we need to identify would be the constant and the lead coefficient. What's the constant here? 3 or negative 3. Okay, so here is our constant. What's our lead coefficient?
3.
Nope.
X to the third.
Nope. Nope, if it was 0, this wouldn't be here at all. You're getting closer. 1. Our lead coefficient is the number in front of our leading variable. The highest degree, yes. So it's got to be in standard form just like every other time. So if there's nothing written there, we know it's a 1. So that is our lead coefficient. The constant is the number that does not have a variable. It's just a plain old number. If we're in standard form, the leading coefficient's always at the beginning and the constant's always at the end. Okay, so to find the possible rational roots, notice on the last slide it said possible, we take the factors of the constant. So in this case, that would be factors of negative 3 over factors of our leading coefficient, which in this case would be 1. So factors of 3 over factors of 1. That means we're going to come up with several different numbers. What are the factors of 3? 1 and 3. Or they could, if they could either both be positive, they could both be negative. So the factors would be plus or minus 1, comma, plus or minus 3. What about factors of 1? Plus or minus 1. So any combination from here is a possibility. It doesn't mean that they all are. It means that they're possible. So let's make a list of possibilities over here. Possibilities. So any numerator-denominator combination is a possibility. So I could have 1 over 1, or I could have negative 1 over 1. Should I also write negative 1 over negative 1?
Yes.
If I already have 1 over 1, do I need it?
No.
No, because negative over negative is a positive. So what this amounts to is we could have plus or minus 1, right? Okay, then let's move on. We could also have plus or minus 3, because again, 3 over 1, or negative 3 over negative 1, negative 3 over positive 1. Do we see how we repeat those possibilities? Okay, so we can choose any combination of numerator and denominator. So how many possibilities do we have?
2.
Nope.
Oh, wait. 4.
4, because we could have positive or negative of either number. How are we going to know which of these possibilities actually works? We can plug it in, or we could use synthetic division and look for a remainder of 0. Okay, so it's up to you, whichever way you want to do it. I need to erase this factors of, so I've got space. Did we all get that down so that we know where we came up with our possibilities? Okay. Now, it does not matter to me which way you want to go about this. For, let's see, for positive 1, I just want to plug it in, right? Because I think for 1s, it's going to be quicker just to plug it in. So I'm checking positive 1. What's 1 cubed? What's 1 squared? What's negative 3 times 1? What's 1 plus 1?
2.
Okay, what's 2 minus 3? What's negative 1 minus 3?
-4.
Does this one work?
0. No.
How do we know this doesn't work?
Doesn't equal 0. -4 doesn't equal 0.
Negative 4 does not equal 0. So that means if I were to write out my list all individually, I can go ahead and cross off positive 1. That is not going to work. Questions about that? Okay, so now we move on to the next number. All right. So now we've got to do it with a negative 1. So I am going to erase most of this. I'm going to add parentheses around these ones that have exponents. When you've got a negative being raised to an exponent, you need to be a little bit more careful with it. Negative 1 to the third power is negative 1. Negative times a negative times a negative. Okay, plus, what is negative 1 squared? 1. Negative 3 times negative 1. Plus or minus 3? Plus 3, and then there's a minus 3 on the end. Okay, you might already notice what's going to happen here. Negative 1 plus 1. 0 plus 3.
0. 0.
Whoa. 0 plus 3?
3.
3 minus 3?
0.
Does this one work?
Yeah.
Yes. If we get 0 equals 0, this one does work. So we want to circle this one, put a big happy face by it on our list, something. This one works. No, because we got to find all of the rational roots.
So we get to do this 2 more times for 3 and negative 3?
So we get to do this 2 more times for 3 and negative 3. Again, if you would rather use synthetic, you can do that. Do we want to use synthetic for these last two?
Which is faster?
It depends on what you're better at doing. Let's look at what synthetic looks like for this.
Synthetic by putting the positive 3, change to negative 3, and put it into the box.
So if we're using these numbers, they are not in parentheses with an X, right? So we use the actual number.
Okay.
So either way on this one, right, we need to test the positive and the negative. But we're using the actual number. What are my coefficients across the top?
1, 1, -3, -3.
Okay. Drop the 1, multiply, add, multiply, add, multiply. Is this going to work? Does this one work out? No, because we don't have a remainder of 0. So we can cross positive 3 off our list. So now let's check our last one. Negative 3. Drop the 1, multiply, add, multiply, add. Okay, it didn't work because our remainder isn't 0. Okay, so the only rational root that we have is -1. Now, if it said find all the roots, we'll have to do a little bit more work. But if it just says find the rational roots, we're done. So pay attention to what the directions say. If it says the rational roots, these are the only possibilities we have. This is the only one that worked, so -1 is our only rational root. We probably should write it as x equals -1. And that's our answer. So remember to come up with our possibilities. Which two numbers from our equation do we need to focus on?
8 and 1.
Okay, 8 because it is the constant. And then 1 in the front because it is the
Leading coefficient.
leading coefficient. Good. When we make our fraction of possibilities, okay, we're looking for the factors of what on top?
8.
8. Factors of the constant go on top. What are our factors of 8?
1 and 8.
1 and 8, 4 and 2.
Okay, 1 and 8, 4 and 2. Any others?
No.
And I should always remember to put plus or minus on all of them. Okay, in my denominator, I want the factors of 1, which is our leading coefficient. So it's always factors of the constant over factors of the leading coefficient. That's why I asked you to write that somewhere on your note page. Okay, so when we go off to the side here and we make our big list of possibilities that we're going to try, what's going to go on it?
1.
Plus or minus 1. What else?
Plus or minus 2.
Plus or minus 2.
Plus or minus 8.
Plus or minus 4, plus or minus 8. It's easier when our denominator is a 1, a plus or minus 1, right? Because any of these over 1 is just going to be that number. Sometimes it's possible that we would have another number up there, which we'll see that soon, or another number down there, okay? But for now, we've got positive 1 or negative 1, positive 2 or negative 2, positive 4, negative 4, positive 8, negative 8. Again, it's up to you how you want to check this. If you want to plug in, that's fine. I think, personally, I like synthetic division. But it's up to you. So I want you to start checking these possibilities and see if you can find which one or ones are going to work for us. And we'll talk about it in a minute. All right, who thinks they found a number that works? India, what do you think? 4. Anybody think another one works?
No.
I think positive 4 works.
Yeah.
Any other? Ooh.
No.
All right. So positive 4 is the only one that I've heard. So let's check that one. So if we check with synthetic, we put a 4 in the box. That's when we're checking. What numbers go across the top?
1, -4, -2, 8.
Okay. And then we do our process. We drop, we multiply, we add, we multiply, we add, we multiply, we add. We got a remainder of 0. So yes, I would agree that x equals 4 is a rational root. Okay, so we would need to check all of them to make sure that none of the other ones work. Which, yes, is a lot of work. I understand that. The directions now say find all the roots, meaning not just the rational ones. Okay, so in order to find all the roots, we are going to start with the rational ones because they didn't give us one to start with. Before, you've always been at least given one to start with, or you could find a GCF, or you knew to factor it using some pattern. Now, none of those helpful hints work. So we have to find our possibilities first. In order to find our possibilities, we need the factors of the constant over the factors of the coefficient. What is my constant? And my coefficient? Okay, my leading coefficient's 2. My constant's -1. So I am going to be putting plus or minus. What are my factors of my constant?
2 and 1.
My constant?
Oh, 1. Sorry.
Just 1. And my lead coefficient is 2 or 1. So plus or minus 1, plus or minus 2. So this time it's a little bit different from what we saw before. Now we have more than one number in our denominator. So for our possibilities, we got to have plus or minus 1 over 1. What is that going to give us? Just 1, plus or minus 1. So a positive 1 or a negative 1. Or we could have plus or minus 1 over plus or minus 2. What options does that give us?
Plus 2 minus 2.
No.
Plus 1
Good. Plus or minus a half or 0.5. So a positive 1/2 or a negative 1/2. These are our options. We only have 4 of them this time. Okay, it's not bad. So we need to go through and check them. We are looking, if we're using synthetic division, for a remainder of 0. So I'll start with positive 1. What are my coefficients along the top? Okay, we drop the 2, we multiply, we add, we multiply, we add, we multiply, we add. Does this one work? No. Okay, so I'm going to cross it off my list. That one doesn't work. What do we want to try next? Okay, we could try -1 next. So we drop the 2, we multiply, we add them together, we multiply, we add them together, we multiply, we add. Does this one work? No. Okay, anybody think they know which of these two is going to work? Positive 1/2? You saw into the future or you tried it out already?
No, it doesn't work.
Negative. I said negative.
So we want to try -1/2? Okay. Drop the 2. What is -1/2 times 2? Positive or negative? Negative. Okay, we add -1 and -1. No. Careful. -2. Don't make silly mistakes on these problems. -1/2 times -2. 2 plus 1. 3 times -1/2. That would be a -1.5. If we add those together, what do we get? negative 2.5. Either way, it's not 0. So does negative 1/2 work?
No.
So let's try positive 1/2. All right. 2 times 1/2.
What, 1?
1. Negative 1 plus 1.
Negative 2.
Nope.
0.
0. 0 times 1/2. 2 plus 0. 2 times 1/2. Negative 1 plus 1. Does this one work? Oh, thank goodness. Okay. Because this one worked, I don't want to erase what I've got yet. If you find one that works and you have to find all the roots, this goes back to like what we were doing in the beginning. And that problem I said you didn't necessarily have to write the whole thing down, because we then use these numbers at the bottom of our synthetic division and plug back in our variable so that we can keep going with this problem. Do you remember that? Okay. So if 1/2 works, then one of our answers is 1/2. So you could write x equals 1/2 off to the side. That's definitely an answer. Now we have to create a polynomial from what's left at the bottom of our synthetic. What's it going to be?
2x squared.
I'll write it down here.
2x squared plus 0.
2.
Okay, do we need to put plus 0x?
No.
No. Okay, but that 0 does go with the x, and so then plus 2. All right, we are going to take that and set it equal to 0. So 2x squared plus 2 equals 0. How do we solve this? Subtract 2 from both sides. We're trying to get x alone. So 2x squared equals negative 2. Then what? No, don't square root yet.
X squared.
Divide. So x squared equals negative 1. Now what do we do? Square root. If
Negative 1.
1i.
close.
1i. Square root 1i.
Square root plus or minus.
Plus or minus 1i. How many answers does this account for? 2. And then we had another one up here, so we've got a total of 3. How do I know that that's on the right track?
2/3.
Good. Look at your highest degree. The degree of this polynomial is 3. We got a total of 3 answers. All right, on example 4, we are finding all the roots. First, we need to know our possibilities. So I'm looking at factors of what in my numerator? 10. What are they?
2 and 5. Plus or minus 2.
Plus or minus.
Plus or minus 5. Plus or minus 1. Plus or minus 3.
Good. Plus or minus 1, 2, 5, and 10. And then in my denominator, I want the factors of 1. My leading coefficient is 1, so that's just going to be plus or minus 1. If you're leading coefficient of 1, it makes your life a whole lot easier. So my possibilities are positive or negative 1, 2, 5, and 10. That's my whole list. Now, as soon as you figure out one of them that works, you can stop testing them, because then we would be able to factor. So I set up my synthetic division. Anybody feel like they've got a lucky guess? Negative 1. Let's try it.
2.
No? We want 2?
2 words.
Okay, fine. All right. Let's show that 2 works. So we drop the 1, we multiply, we add, we multiply, we add, we multiply, we add. Oh, look at that. It worked. Good job, team. Now, we know that x equals what is one of our answers?
2.
2. Okay, so I would go ahead and write that down. As soon as you find one, write x equals 2 and put a big circle on it somewhere.
So it would be x equals -2.
No. The only way x equals -2 would work is if we put a -2 in our little box and synthetic division worked out. Sadia?
Will there always be only one that works?
Yeah.
Because what if we end up just checking this one time and we already find one that works and then we don't check any other ones?
So, that's a good point. So if you're trying to find all rational roots, that's when I would definitely check them all, because that way you don't have to worry about factoring further, right? But if they're saying find all the roots, if you found one of them and you can set up a polynomial with what's left from your synthetic and be able to solve it, then you don't have to keep checking because you'd be able to find that root anyway. Okay, in this case, on this particular problem, I can look at it and tell you x equals 2 is the only one that would work. Because when we set this up down here, what equation does this become?
X squared minus 5.
Equals?
0.
Okay, so I'm going to like carve out a little space in the middle here. X squared minus 5 equals 0. Do we all understand how Sadia got that?
Yeah.
Okay, good. What are we going to do to solve it?
Add 5.
Add 5 to both sides. You don't have to show that step. X squared equals 5. And then we're ready to square root. Are we going to need an I? No. That's why not?
So x equals plus or minus.
Okay, good. The 5 isn't a negative, so x equals, I heard some people say the plus or minus, which is good. Plus or minus the square root of 5. Square root of 5 doesn't simplify, so that accounts for our other two answers. Okay, we will stop the notes there today.